Hello and welcome to another session in mathematics. Today we'll be looking at the Venn diagram. But before that, let us look at the previous lesson. Welcome back. We're looking at the Venn diagram today, and we'll start with the definition of the Venn diagram. Okay, the Venn diagram is a representation of members of a set. In a diagrammatical form. Okay, and this Venn diagram can be used in solving problems like union of sets, intersection of sets. It can be also used in solving the complement of a set. Okay, and the things I want you to understand them in this Venn diagram. You'll be encountering things like a rectangle, and this rectangle here is what we call the universal set. You remember, the universal set is the set containing containing the other subsets. From the universal set you can get your subsets. So the universal set is the set containing every member where subsets are being formed from. Okay, then this is what we call what? The universal set. Then apart from that, inside the universal set you will see an oval-shaped set, and this oval-shaped set inside the rectangle are the subsets. Sometimes it can be 2, it can be 3, and so on and so forth. So we call them what? The subsets. And then when the oval shapes lap together, like have something like this, then at this point we call it what? The intersection. Okay, when they do not overlap, you have something like this, then we say that this is a what? A disjoint set. Okay, and then when we have numbers written outside the set but written inside the universal set, we have numbers written in this form, then we call them what? The complement of this subset. Let me explain that better here. Assuming we have a rectangle of this form, and then we have A, and this is B, and in B you have numbers, and also we have numbers in A, and then outside A and B you have alphabets. I say A, B, C, D, E, F, and the rest of them. Now these alphabets inside this universal set are what we call the complement of A and B. Assuming we have this as our A, and there are numbers 1, 2, 3, 4, 5. These numbers inside are the complement of A. They are complement because they are inside the universal set, but they are not what? In the subset. You remember, the complement of a set are those numbers that are in the universal set, but they are not inside the what? The subset. Okay, so let's quickly rush down to some examples in this Venn diagram. Okay, let me teach us how to draw the Venn diagram. Like I said earlier, this is the universal set. Okay, universal set, and when we have subsets inside A and B, for instance, we call this point, the shaded point, is what we call the intersection of A and B. Okay, intersection of A and B. That's the first thing you need to know. Then when we have another bus of this form, we have this, and we have this. When we have something like this, then, and this place is shaded, this place is shaded, then we call this the intersection of P and Q prime, given that this is P and this is Q. This is our P and this is our Q, and then Q complement means the numbers that are in P but that are not what in Q. So these letters inside P that are not found in Q are called what? The what? Q complement. Okay, so taking the intersection, which is here, we have that P, we have that this bus signifies P intersection what? Q complement. Okay, this is number 2. Then for number 3, if we have this bus is called them A and B, and everything here is shaded, we call this A union B. A union B means what? The combination of the two sets A and B, like bringing them together without the repetition of what? Any number. You remember what we said about union? Yeah, so this is union, this is intersection, and then this is what? Complement. Okay, let's continue. When we have something like this and the outside is shaded and nothing is inside, like the elements are outside the bus, which is let's take this to be A, where this is our universal set. Now set A has no element here, but every number is inside the universal set. Now when we have something like this, we call it what? A complement, or you can say A raised to power C. Okay, it's something you can use A raised to power 1 or A raised to power C. It simply means what? A complement. That is the numbers that are in the universal set but not what? In the set A. Okay, that is what complement means. Okay, that's number 4. Let's proceed. Assuming we have another universal set and we have something like this. Now this is A, this is B. We say that A and B are disjoint what? Sets. They are disjoint sets. They are disjoint because they have nothing in common. Okay, they have nothing in common. Okay, then when we have something of this nature, okay, where this is our Q and this is our P, we say that P is a subset of Q. P is a subset of Q because P is inside what? Q. Q is the universal set, while P is what? The subset. Okay, now when we have something of this nature and we have this, and we say that this is let's say this is B and this is C, and every part of the universal set is shaded. That is, the numbers are outside the universal set but not inside A and B. When we have something like this, and then we call it this is 7, we call it the complement of B intersection the complement of C. These are the numbers inside the universal set. This is the universal set. They are inside the universal set, but they are not inside what? B. That's how we got this complement. Then this intersection is this, and the numbers that are in the universal set but not what? In the set C. Do we understand? Okay, then when we have something of this nature, then there is a mark here. This is where we shared. We call this the A, B, C. And then what do we call this? We call this what? The intersection of A, B, and C. So A intersection B intersection C. Is that correct? Okay, let us look at this. We have 1, 2, 3, and everything inside them is shaded. If everything is shaded, then that means what? The combination of what? The three sets. Let's assume this is Q, arrow, and this is S. So it means what? The intersection of Q, arrow, and what? S. So it means what? Q intersection R intersection S. Okay, so having studied the representation of the Venn diagram, kindly provide the answers to the following questions on the screen. Welcome back. So far we've been able to define Venn diagram. We've been able to look at the properties of Venn diagram and how to draw the problems of intersection, union, and complement using the Venn diagram. We'll call it a day here. In our next class, we'll go over to the use of Venn diagram to solve problems involving two sets. Do well to use the lesson note on the platform for better information on the topic we've discussed. And feel free to drop your question on the comment section. Till we meet again, stay safe and bye.